Number 24 in 5.8 is a problem that looks absolutely horrible. If you looked at this problem and said, oh, heck no, I'm not even trying that one, I should yell at you, but I kind of understand where you're coming from. That said, we're going to dive into this one, and I think you're going to find this is not as bad as it looks. So the big takeaway from this problem, and the reason I assigned it right here, is because, and you guys saw this in your notes in 5.7 and 5.8, quite often we end up with integrands that are rational functions, meaning fractions, with variables on both the top and the bottom. And in most of the cases where your integrand has variables on top and bottom, we usually are going to look to the denominator of our fraction to get u. Okay, that happened in, let me think, the second example in the 5.7 notes where there was a square root of a quadratic trinomial on the bottom. We let u equal that radicand. And also in the third example, the stan x dx problem where we did the integral of tangent by splitting it into sine over cosine. And in most cases, we let u come from the bottom. But there was one example there, and I think it happened at the very end of 5.7, that kind of flipped that around a little bit. The exception to that, guys, is that if you ever end up with a natural log in your numerator, something interesting happens with that natural log that makes the secondary substitution easier, and in fact possible, than it is in most cases. So when you have a natural log of something in the numerator, very often that's where you're going to go to find your u. We're going to let u here equal the natural log of whatever comes after it, and in this case that is going to be the inverse cosine of x. So if we're right about that, that is your primary substitution right there. Okay, so I kind of like to build this as I'm going along here. This would be the integral of, and the natural log of inverse cosine of x just becomes a u. Okay, the secondary substitution is everything that's left over right here. It needs to be dx divided by, that's what's interesting here, dx divided by inverse cosine of x times the square root of 1 minus x squared. And if you have no idea how we're going to get there from where we are right now, again, I would understand that. But let's dive in and see what happens here. Okay, so I'm going to change back to green here. And when we go to take the derivative of both sides of this equation, let's think. How do we take the derivative of natural log of anything? Well, if we remember this from chapter 3, it is going to be 1 over whatever product you were taking the natural log of. So in this case, it's 1 over the inverse cosine of x. Wait, but there's more, times the derivative of that product. And the derivative of inverse cosine of x is negative 1 over the square root of 1 minus x squared. So the negative, I'm just going to multiply by the existing positive 1 to get a negative up on top, times the square root of 1 minus x squared. And of course, there's a dx at the end of all that. And what I want you to notice is, guys, as awful as this thing looked right here, this secondary substitution, that is precisely what we have right here with the exception of that negative. So how am I going to solve that? I'm going to take the opposite of both sides. The left side now becomes negative and the right side now becomes positive. And I can just ignore that. So cool. This entire mess right here, check it out, guys, can all be replaced by a negative du. So that's really, really interesting here. That means I can put a du at the end of all this. A negative, remember that's really a negative 1, can go way out in front. And I didn't actually need to make a fraction here because there's nothing to put underneath the u. I didn't realize that at the time. So here's where we're at, guys. So as nasty as that one looked, it actually was a relatively straightforward secondary substitution, and the rest of this now is pretty easy. When we anti-differentiate a u, we're going to have the negative from out in front, and then a 1/2 u squared, and then a plus c at the end of all that. Now, this gets ugly, but it's certainly not difficult to put the x's back in for the u's. So a negative 1/2 times, and u is the natural log of the inverse cosine of x. So all of that takes the place of the u. That's all getting squared, and a plus c at the end. So it looked like a really, really, really hard problem, and it ended up really not being all that bad. So the moral of the story, guys, what I want you to take from this is that when your integrand is a rational function, meaning it has variables on both the top and the bottom, usually you let u come from the denominator. But if the numerator contains a natural log, then in that case, you very often want to let u come from the natural log of whatever you have up there in the numerator. So that's the big takeaway from problem 24.